Good morning. So we'll start. So I'm Hansa. I'm a trainer and analyst here. So today we'll be looking at GIS and BIM integration for smarter urban infrastructures. Okay. So first we look at what is BIM. Okay. So it is BIM basically stands for Building Information Model. And it is the process of creating, managing, and sharing this digital information, detailed digital information, the metadata that we store with the models, right, about like a building throughout its life cycle, like from creating it, like from the basic concept to the demolition phase, everything together is BIM. So it is basically bringing together the geometry, information, and the time to deliver, right? So it helps us with better decisions, and it knows, like, so when we talk about BIM, we know what it is, what it does, and how it fits into a building's life, right? So that is BIM. So then let's talk about GIS. So GIS is again creating, gathering, managing the geospatial data. Okay. So the data here is tied to the location. It basically turns the addresses, coordinates, and areas into answers. So when we talk about integration, okay, we have main three concepts. First, we have the model, okay, which we get it from Revit. Not Revit necessarily, Revit or any of the other softwares that you're using for building these models. So when you get the model into GIS, into any of the GIS softwares, first thing is to give the spatial reference. Because when you're creating these models in the software, you're using local coordinates. So any object that you're designing, it's like you're using that one particular coordinate to design that one object. It could be walls, floors, whatever you're designing. But when we come into GIS, we are using more of a global coordinate system. Okay, so first thing is to give the spatial reference. Okay, that is the first thing. Only then your model will sit at that particular location, and then only you can proceed with the further analysis. Because if the model is not located at that site or the location for which you have created, then further analysis also is not possible, right? Okay, so that is one. One more thing that we have to make sure is the data compatibility. Because here the data formats that we are using is IFC or your RBT files. Whereas here we are using your multi-patches, shape files or feature classes, right? So we have to again make sure that we are cleaning the data or making it compatible to add it into GIS software. Again, because BIM, since you're creating the models, you'll have heavy data sets. Okay, and then doing the analysis again, doing the analysis in the GIS software is going to take time. So whatever is just required, only those data has to be imported into your GIS software. Okay. And then based on that, we go with the analysis. So now let's look at the workflow. Okay, so how, like the basic workflow, this is just a structure. So based on your analysis, one or two steps may again move up and down. So now let's understand this with an example. Okay, so I have a model. Suppose maybe I'm creating a model for a school or a hospital. It could be anything. Okay, so now I have to add that model to my GIS software. So that is just the design that I have. Okay, maybe floor, the utilities, everything. Okay, I can have I have some information in the model. Okay, one more thing, attributes is also one thing, because when you're creating a model, right? You will be adding a lot of information there. So all that information is also getting into your GIS software. Okay, so that is one more thing. So that also comes under your when we look at the integration, that is one of the important aspects that we have to look into. So now the workflow. So first is to make it compatible. So when you're adding it into, suppose if I'm taking an example of ArcGIS, when you're adding it into the software, it has to be compatible. Okay. Then once you're adding it, you have to assign the spatial reference because we are using local coordinates when you're creating the model. But here we are using more of global coordinate system. Right? So now I have a model. Now I want to suppose let's take hospital say. Okay. So now I have to first I'll add it to my GIS software. I have to give the coordinates or georeference it or assign the spatial reference. Okay. So once that is done, so the next is I have to do the analysis. So now what are the analysis that I'll be doing? Like I have the model imported, everything created is the BIM part. Now the analysis comes into the GIS part. So what are the analysis that I need? Suppose if I want to see there's a hospital where I need probably the traffic data, the road networks, like in cases of emergency, or it could be maybe disasters, flood. During flood, what is the accessibility to the hospital, evacuation routes, right? So all these would be part of the analysis. So I may need the road network, I may need the traffic data, I may need the elevation as well. When I'm looking at flood-based analysis, if it's just traffic, I'll need the road data, traffic data, and maybe other nearby what are the nearby buildings or what are those present, right? So that would be basic. So that is preparing your data, then making it, when you're preparing again, you're making it data compatible, you're importing it into your software, GIS software, then you give the spatial alignment, you do the spatial alignment, and then you go for the analysis part. Okay. So the key softwares or tools that we may use, one of them for GIS is ArcGIS, and all the modeling part, the BIM part, that will be done using Revit. So let's see a practical part of this. Okay, let's just go through one. So we'll be doing flood simulation. So I'll be using the base map itself for this. So I'll be using ArcGIS for this. So since we are using 3D models, so like since we are working on 3D models, we usually use the scene layer, the local scene or the global scene. Local scene, if you're using a smaller, if it's text for a smaller area, you can go with the local scene. Okay, so since I'll just do it up, I'll be showing it just for a very small area. So I'll go with the local scene layer. I'll change the base map. I'll use any one of these so that we just have a 3D models for the buildings. Okay, so instead of this, you may have your own like data. You can add the IFC or the RBT files. You can georeference or just assign the coordinates, and then you can proceed with the analysis. So I am taking, I'll be showing flood simulation. Okay. So using that, so I'll be taking an area somewhere around Chennai. Just take any small area for now. Just a minute, it's loading. It takes a bit time to load. Okay, so you have the base map, you have these buildings. So just using this. Okay, so I'll take this smaller area, this much. So on this simulation, so I'm actually doing this when there's during rainfall times, right? So with the rainfall, how is where all you'll be having more of water logging, right? Based on the intensity of the rainfall, based on the existing maybe the water areas, the elevation. Okay. So here under simulation, I'll give it as rainfall because I want to know what are the which regions would be flooded first. Okay, when there's a rainfall. So first I'll have to define my study area, okay, or the region or my area of interest. So first let me define the study area. So I hope you can see this here. You have this yellow bounding box. So this is the extent that I've given. Okay, so only the analysis would be the simulation would be done just for that much area. Okay, so here this is the bounding boxes. Okay. Where if you follow the cursor, you can see the bounding box. Right. So once I have defined the area, so here you can see you get the simulation options to set the simulation parameters. So this is the duration. You can set the duration of the rainfall and the rate of rainfall. So you can set it in mm or inches. Okay. So now I'll run the simulation just for 5 minutes. Okay. Otherwise it will take time. So I'll just run the simulation for 5 minutes and I'll increase the rate to at least 100 so that you can see at least the areas which will be flooded. Because with if I give a lesser intensity and the time is also less, this is 50, I will change it to 5. So you will not be able to see much of the output here. Okay. So I'll give a 5-minute rainfall duration with maybe around 100 mm of rainfall. Okay. So you can split. Okay, you can also add according to the time you can split it. You can have different intensity of rainfall with each time because it won't be the same intensity the entire duration of maybe 1 or 2 hours or how much ever duration your rainfall is happening. So participating layers, right now I'm just using the base map. Okay, so when you have a model, here you have to select the model. Okay, your model, if you're adding, when you're adding the model will option, the model is going to appear here, so that will be a layer for which you will do it. So then you have your starting water level. So if the area is already flooded, okay, so that is what you're giving in starting water level. So you're defining that this much water is already present. So then there is a rainfall, that level is going to increase. Okay. So for this water depth raster, you may need the elevation values and the water level. So if you just subtract those, you probably get the depth, whatever is the water depth, right? So you need the elevation values. You can probably use your digital elevation models here, and you need the water level, the current water level that you have. Then you have infiltration rasters. Infiltration raster is how quickly the water flows. Okay, so you may have impervious surfaces, like where you have buildings and all, right? You may have your water bodies, you may have your vegetation areas. So if you just check this, so you have impervious barren land, right? Forest, dry grass. You can select any one of these, or you can again create your own infiltration raster. So for this, what you need is, so you need like a topographic map, sort of that that is like you need there each and every feature. Like you need if the buildings are present, if there's any bridge, if there's any water body, if it's a road, if it's a landfill site, like everything has to be created there, right? So you can create it and then convert it to a raster, or if you have it already in raster form, good. So basically you need the land use data for this. Okay, so that would be your infiltration input. Then you have the maximum infiltration. Maximum infiltration is how much water can it take, like absorb basically. After a certain ArcGIS version is no, this simulation can only be done in higher versions. The latest versions of ArcGIS. This is not possible with the previous versions. I think above 3.2 you need to do the simulation. Like this simulation, if you want to do, you need more than 3.2 or higher versions you need for ArcGIS to do these simulations. Okay, so maximum infiltration is the maximum amount of water that your soil can hold. Right? So that is the maximum extent, the saturation level. Then you have the surface roughness raster. The surface roughness raster is again the type of materials. So the water flow basically will be smooth along the not smooth, basically fast along smooth surfaces, and it will be a bit slow along rough surfaces. Okay, so that is your surface roughness raster. Okay, so I'll just quickly run the simulation. So once you've given the layer, the duration of the rainfall, the intensity or the rate of the rainfall, infiltration raster, surface roughness, starting water level. Okay, starting water level, if there is any already flooding has occurred, then for that you have to give it. Okay, if you're just doing it for probably analysis part without any previous flooding data that you have, then you can just leave the starting water level. Okay. So once it is done, so you can run the simulation here. Again, you can also set the evaporation rate when you're running the simulation, because there may be some evaporation as well, right? So if you have the evaporation rate, even that would be set here. So just quickly one more thing before running. Here you have the option to also add these other parameters like channel. Channel is basically where the water flow is already there, right? So during flooding and all, so starting, maybe the channels can take up some of the water, but again, if it's reached its maximum capacity, it's going to overflow, and again the surrounding regions are going to get flooded, right? So that is channel. Water area is existing any water bodies you have, like because whatever you have existing areas, especially for coastal areas, you will have these water areas. So in that case, you can also add your water area. Barriers are again, like you may have installed barriers which is probably preventing the water flow into that area. So those are your barriers. Yes. Dam is a barrier. Okay. So I'll just run the simulation quick. Okay, so now let this run. This may take some time. It's very slow. So now, for example, now this analysis that we are doing. So if I'm bringing a model in here, okay, so if I'm FOC, so the area that I'm probably trying to build, or maybe it's not already created, maybe I want to create it then. So it would be like a site script. Right? So for example, if for a particular area, with the elevation values, if it's a low-lying area, or if suppose if I'm creating it at somewhere around this location, it would be a low-lying area. If it's a low-lying area and increased rainfall, the chances of flooding is more. That is one. Second thing is, now if suppose if this is where most of seepage is happening, or most of water is actually entering the ground, and if I'm blocking that again by constructing or placing a building there, okay, that is again going to this, you can also plan your evacuation routes. So since you know which are the areas which will get flooded first. So it actually, as it runs, it will show which are the areas which will get affected first. Okay, so I think it will take a bit time. Let's wait for just 2-3 minutes. So once we see at least where all we have the areas which will get flooded, we'll stop till then. So based on whichever areas are getting flooded first, or which areas will be affected first, based on that we can plan the evacuation. The simulation is still running. So here, if you see a few of the areas, you can see a bit of waterlogging here and there. It's just like it's not 55 seconds. If you see all these locations, okay, so these are all the areas which are going to get affected first. Again, if these areas are like prime areas in terms of like schools or hospitals, like certain important facilities. So there, probably so for all those locations, first the evacuation routes have to be planned. Let's just see. So you can export all these, like you get these as images. Okay, so you can export these as 3 or 2 different data sets. We'll just wait for another 1 minute. Let's see how much of area is getting flooded, and then we'll just export the result. We'll see the export settings. Export will again take a bit time. So you can check the water depth, the speed, flow rate, the direction. Right? Okay. So see, here we have water areas and not added any. Okay, so if any channels, barriers, water areas, you can add it here. I think you can see here all these blue patches that you see or the dots that you see, those are the areas that are actually starting to get like water logging there. So I'll stop it for now because it's going to take time. Let it run. So then here you have the analysis results. Okay, so under analysis results, you can set how do you want the export. Okay, the layers cache interval it will take according to whatever layer you have. So here I've given it like 5 minutes. Right? You can set it according to the number of iterations. So the layer cache interval is going to generate 12 timestamp images. Okay? You have 3 different data sets, or you can also set it according to the time. Okay, so if you want the images 5 minutes in the interval of 5 minutes, or you want it for every minute. Okay, you can set that, or you can set it according to the number of iterations. Okay, so those many images would be generated if you are setting it as number of iterations. Again, you can set the initial state. Initial state would be if it's already flooded a bit, or if you're just there's no flooding, you just see okay at particular duration of which areas are going to probably get flooded. You can export this in CRF or TIFF format. Okay, so I think it's still running. So like this gives you a very like rough idea on. So this is just a very small aspect that I talked about, like flood simulation. And I mentioned about probably blocking maybe the drainage systems or the flow, or if you have already pre-flooded area, okay, how much more damage is going to happen, or probably what would be the possible evacuation routes, which areas are flooded first. Okay, this is just a very small aspect. Again, I told you can use elevation data based on using them. You can use the elevation values. So you can have many more such applications. Okay. So one more application is other than flood simulation. You can have, say, for example, sustainable, right? Smart cities that we have these nowadays, right? Sustainable development. So where probably, especially with installation of solar panels and everything, right? So based on the building height or the whatever nearby buildings you have, the sun's the sun angle of the height and the time of the day, the shadows of the surrounding buildings, right? So based on that, you can identify the most suitable location where you can place the solar panels, right? So that you get your the process is more efficient that way, right? So for that you will need again elevation. You may probably you may need the slope values. Okay, you may need the the sun's angle and the height at which it is, the time of the day, right? So that is basically the time of the day. The height and the angle is going to give you the time of the day, right? So you can see here, okay, it is showing the areas which are going to get flooded, initially going to get flooded. So when we are doing this, so we talked about certain prerequisites, right? So the same are actually also part of the challenge that we see. Now again, so like for example, your data interoperability. So this is again your data formats. If it's not compatible, right? If you're not able to import it into your software, so the analysis again can't be done, right? So it has to be made first data compatible. Second is coordinate alignment. Okay, so it has to be given a proper spatial reference, because the wrong spatial reference will again mess up the entire analysis part that you're doing. So the challenges and the prerequisites, they are the same, right? So we are trying to address all these challenges with those points that we just talked about under prerequisites. And again, large data handling, that is cleaning your data, just adding the data sets or the attributes that we are creating, only the necessary ones, because it takes time. And doing it like for an entire city or a larger area, okay, it is going to it will be time taking as well. Okay, and the data sets, the size, the files are going to be huge. So those are the challenges that we may encounter. So what are the other applications that we can have? So as we talked about this solar panels, sustainable cities or smart cities, then integration. So these are some of the other applications that we can have. So like a smart city, for example, you may have a utility networks, right? You create all these. So all those networks, the flow of the network can basically be traced using your GIS software, right? So again, that is one application that we can have. So we have such projects, like smart city projects, like it has been, I think, implemented in Bhubaneswar, Pune. So all these places it has been implemented. Like these utility networks, and these have been basically this integration part has been used there, right? So to conclude, so when we integrate, so just the models we have, but when we are combining it with location, we are able to identify certain patterns, right? Probably we will predict based on that location, right? And it also makes the entire process more efficient.